Oceanography Homework, The Geologic History of Iceland, Lisa M. Elms. Iceland's creation. The geologically young land, Iceland, is located on both the Iceland hotspot and the Mid-Atlantic Ridge, which runs right through it. This location means that the island is highly geologically active, with earthquakes and many volcanoes. This island is composed primarily of basalt, and Iceland has hundreds of volcanoes with approximately 30 volcanic systems active. The country lies between latitudes 63 and 68 degrees north and longitude 25 and 13 degrees west. Geological mechanisms. The tectonic plates whose turbulent interactions formed Iceland are the Eurasian tectonic plate and the North American tectonic plate, spanning the Mid-Atlantic Ridge. Iceland emerged as a result of the divergent spreading boundary between these two plates and the activity of Iceland's own hotspot or mantle plume. As the plates moved apart, excessive eruptions of lava constructed volcanoes and filled rift valleys. Subsequent movement rifted these later lava fields, causing long, linear valleys bounded by parallel faults. The divergence of the ridge started in the north about 150 million years ago and 90 million years ago in the south. These movements continue today, accompanied by earthquakes, reactivation of old volcanoes, and creation of new ones. Iceland is the largest island on the ridge because of the additional volcanism caused by the hot spot beneath the country, which moves slowly towards the northwest. And as you can see, Iceland has nearly 500 earthquakes each week, and most which are linked to volcanic activity. So many agree that Iceland's hotspot was originally beneath Greenland about 70 to 40 million years ago, and other studies on the hotspot conclude that the geothermic heat flux over Greenland say that it moved under Greenland between 80 and 50 million years ago. Some researchers, using new plate tectonic data gathered from hotspot reference frames from around the world, suggest that Iceland hotspot's path differ from the estimated from older investigations. Many older rocks dated 75 to 70 million years ago, located through the area to the west, are not only located near hypothesized Iceland hotspot paths, but are also attributed to hotspot volcanism. These imply that the Iceland hotspots may be much older than the earliest rifting of what is now the northernmost Northeast Atlantic. If this is true, then much of the rifting of the North Atlantic was likely caused by thinning and bulging of the crust, as opposed to the most direct influence of the mantle plume, which sustains Iceland hotspots. In other scientific work on the path of the Iceland hotspot, no such westward track toward Canada can be detected, which implies that the older igneous rocks found in the northern Atlantic may not have originated from the hotspot. Although the exact path of the Iceland hotspot is debated, a preponderance of geophysical evidence, such as the geothermal heat flux over Greenland, shows that the hotspot likely moved over Greenland around 80 to 50 million years ago. And as I stated earlier, the island is made of mostly basaltic rock, as a result of solidification of magma from the volcanism. So, Iceland's future. So the biggest threat is climate change. With the temperatures changing and the North and the South Poles having extreme warming and the polar ice caps are melting, that is causing the mantle to flow down and cause more magma, which are creating more earthquakes and more volcanoes to erupt, and that will cause more spreading of the island. So we will experience more extreme weather, such as more hurricanes, and more earthquakes, tsunamis, and things of that nature, which will affect everyone in the world. So the two tectonic plates around Iceland have formed a land bridge, and they spread apart. This feature is known as the Greenland-Scotland Transverse Ridge, and it now lies below sea level. Around 36 million years ago, the Iceland hotspot was fully in contact with the oceanic crust and possibly fed segments to the mid-Atlantic ridge, which continued from the oldest rock located directly to the east of the modern-day Iceland. I hope you enjoyed this presentation. Have a great day.